All right, final video, part 3, graphing trig functions. Here's two of your very, very important parent functions. Let's attack this. Notice I like a little bit on the left, a little on the right. Goes through the origin, up to 1, back to 0, down to -1, back to 0. And let's take a label the axis. Well, I don't even know what that, oh, we did. All right. So notice a couple things about the parent function. The entire period is 2 pi, or 360, depending on the way you look at it. The amplitude is 1. You could have also chosen this, but that's -1, and the formula is the absolute value of a. And there's an a there, so you could have just taken the absolute value of 1, which is 1, whatever. Cosine. Let me pause this, save you some seconds. All right, the key to graphing cosine, it goes over the origin, back to 0, back to -1, back to 0, back to -1, makes a little curve because it would continue. When it does say 2 complete cycles, so maybe I would have just kept going like this and just get the general idea. If you could do a little more than 2, it's fine. So this would just go up, then come down, something like that. All right, so there's 2 cycles. So now it says, given the function list all the transformations. It just says list, doesn't say graph. So that's over the x, vertical stretch 3, left pi over 2, down 4. Save you some time. What's the period? Well, the period formula is 2 pi all over the absolute value of b. Notice b is 1. So that would be 2 pi. Nothing's changed because 2 pi over 1 would just be 2 pi. Amplitude would be, like I said, the absolute value of a. In this case, a is technically -3, so that would be 3. That means the peak would be up to 3 and down to -3, but it doesn't say graph. Now it's talking about graphing. Graph 2 complete cycles, I'll probably forget. So let me get this all set up. And here we go. Start with the parent function. Goes over. You got to hit those marks very well. -1, 0, 1, 0, -1. Try to be accurate to get started. So now we're going to introduce some colors. What does that do? Well, it flips it over the x-axis. And then what does the 3 do? The 3 takes the previous adjustment and cranks it up. So it is 3 times 1, not 3 plus 1. I've had students do that before and make it 4 because they add. It's 3 times 1, so it's up to 3. So 1, 2, 3, that point goes there. 3 times 0, 0. 3 times -1 is -3. So I know that's going to look like this. Goes through there and then that goes up. Well, it'd be level, so it'd be like that. Okay, now we've got to move this guy left pi. Well, because we have to do 2 cycles of it, I don't have any room on the left to move it left. So I'm just going to go ahead and add a couple of these. And it goes from here to here in pi. So this is 2 pi. So it's going to look like this. And then I'm going to come back up like this. All right. So I have to move that whole thing left pi. So this is going to move to here. This is going to move to here, and now I can kind of get started. And that's going to move to here. That's going to move to here. And there you go. Is it perfect? No. But kind of gives the idea. And I don't even think we have space for this. Alright, start with cosine, goes over the origin, Got to get that parent function good. Now the amplitude's 5, so we got to multiply that by 5, so it goes up 2, 3, 4, 5. I'm going to make my units a little smaller. 2, 3, 4, 5, just so we can fit it in there. So there's -5, there's 5. This is going to go up to here. That stays, that's going to drop down, that's going to drop down. I'm going to keep this in pencil. And there's a magnitude of 5. Now here comes a little trick. B is equal to 1/3. There's an invisible 1 there. So 2 pi all over B would be 1/3, which is 2 pi times 3. Flip this and multiply, which is 6 pi. Now there's no way we're going to duplicate it going left. So basically we got to make adjustments on the right. So we need 3 pi on one side and 3 pi on the other. And so what I think I'll do is I will stretch it out to here, 2 pi, and then just continue here up to here. And I'm going to focus on, oh, this graph's going to mess with me. So I'm going to just continue. So I'm going to go out to here, and there's 3 pi. And I should have made my units a lot smaller. Okay. Alright, so that one was a little bit of a fail. So let's just reattack it. Cosine. The parent function looks like this. So in all reality, on your test, if you end up with this and you run into problems, what I would do is move this kind of in the middle and just redraw out here and out here. So try to explain what I'm talking about. So here's the parent function, just one cycle. So that's got to go up to 5. So it's 1, 2, 3, 4, 5. Stays, -5. Stays, -5. So it's going to come like this, and like this, and like this. This will work out a lot better. And so now we're going to adjust the period, 6 pi. Notice we're from these walls, -pi to pi. So that's your normal 2 pi. So we've got 1 pi on one side, 1 pi on the other side. So our entire period's 6 pi. So we need 3 pi on one side, 3 pi on the other. Notice I've made it happen. So this point stays. This goes all the way to -3 pi. This goes all the way to +3 pi. So here's my new wall. Here's my new wall. Remember, on the original, halfway point is where it crosses the x-axis from here to here. So now I need to go 1.5, which is right here, and it's just going to be horizontally stretched. 1.5 is right there. And then the grand finale would be to move that entire thing up 1. So we move it up 1, up 1, up 1, up 1, up 1, and then our grand finale is there. And there's no way we're fitting more than one period on this, or one cycle. So we're just going to stop right there, call her good. Alright, a little bit of a zinger. We got to move it up 10, but let's start with the parent function, sine. Up to 1, back to 0, down to -1, back to 0. There's your parent function. You better know at least that. Just move it to the right, pi over 2, which means a chunk. So I'm going to get out some colors. So this adjustment right here is going to look like this. And it's going to move there. So it's just going to be just like that. And then we just have to move that thing up 10. So, I mean, this is down 1. So that would end up, well, every 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that would go to 11 because that's up 1. So there's 11, and then it'd be down 1, and that would be, kind of goes like this, 9. Whoa. And then that would be up. That's pretty bad. But Hopefully you guys kind of get it. That's just moved up 10 units. Bless you back there. All right, grand finale, find x. Where's x? Right there. What's that asking? How far do you spin your spinner to create that situation? What is sine? Sine is opposite over hypotenuse. What do we know about the hypotenuse? It can't be negative, which tells you take that negative, apply it to that. So it's negative square root of 3 all over 2. Well, if we take our little all students take calc thing, where's sine negative? Not here, not here. How could the opposite side be the negative square root of 3? Well, if you remember your 30, 60, 90, your 60 always has the square root of 3 opposite it, so somehow we're going to have to create that story. So this has to be 60 here. That has to be 60 here, because there's your negative square root of 3, negative square root of 3. There's your 2, there's your 2. What is this, x? It's how far you spin your spinner to create that scenario. That'd be 180 plus 60, which is 240. But it would also be 270 plus 30. Well, that'd be 300. All right, so this one we subtract 1, subtract 1. 2 cosine x equals negative 1. Divide by 2, divide by 2. See you, Scotty? Yeah. Cosine x equals, now watch this. This has to be my hypotenuse, so it's positive. This has to be my adjacent side. This has to be my hypotenuse, so you gotta draw a picture. It's all about the spinner. All students take calc. Where is cosine negative? Not here, not here. What is my adjacent side? It's always my x-axis, so I gotta make this negative 1. And remember, in a 30, 60, 90, my square root of 3 is always opposite my 60. My 1 is always opposite my 30. So I know this needs to be a 30 up here, making that 90 and that's 60. Making this the square root of 3 just for kicks and giggles. And then I know that same thing can happen right here. So there's my hypotenuse 2, negative square root of 3. Cosine would be negative 1/2 if I spun my spinner that far, which is 120 degrees, 90 plus that little wedge 30. But it's also if I spun my spinner that far, 180 plus 60, which is 240. And I'm just giving you the dimensions of the triangles just for extra practice. So your brain can lock in, but it doesn't really have anything to do with this or this, as long as you got your negative 1 as your adjacent side. Grand finale, subtract the square root of 3 from both sides. 2 sine x is negative square root of 3. And I haven't really talked about that or that. Ooh, this says for all values of x. I better, grand finale will be right there. Divide by 2, divide by 2. So we got to understand this is saying how far do you spin your spinner to create that story? Well, that's my opposite side. That's my hypotenuse. That's why I knew not to bring that negative down with the 2. Remember what I said earlier? Square root of 3 is opposite the 60. So that's telling me my reference angle is going to be 60. But before we get ahead of ourselves, all students take calc. Where's sine negative? Not here, not here. How can my opposite side be negative square root of 3? Well, that would mean this, this needs to be 60, negative square root of 3, and this needs to be 60, negative square root of 3. And I could really be done, because it really wants to know how far you spin your spinner to create this story. But I'll throw in a few more details just for review. And that's 2, and that's 2. But how far did I spin my spinner? 240. How far did I spin my spinner to get to here? 300. No negative spins. Now this one says all values of x. So this is kind of like a coterminal thing, where if I spun my spinner 240 and it's all values of x, then I could go backwards 360, or I could go forwards 360. So I would go 240 plus or minus n times 360. Forwards 360, backwards 360, n is a whole number. So one time around, twice around, three times around, etc. Same thing here, 300 plus or minus n times 360. A little fancy pre-calc coterminal talk right there. That was a good grand finale. All right, guys, see if there's any questions. Good luck.